What is math freaks? Here we go again. In this video we're going to talk about the distance between a point and a line. We're going to do this using an example. You really want to pay attention to this problem. It can be very difficult, but if you can really understand the conceptual ideal, it'll make your life much easier. So we have a line y equals 2x minus 1. So first I'm going to graph that line. Let's graph the line. 2x minus 1, so we pass through there at -1, and we have a slope of 2. Rise over run, so rise 2, run 1. And so I have, here's going to be a sketch of the line y equals 2x minus 1. And we have the point 2, 1, over 1, 2, up 1. And we want to find the point on the line that is closest to that point. Okay. Note that on the line, that any arbitrary point on the line is going to have the coordinates. Let me go sideways here. The x is going to be the first coordinate, and the second coordinate is going to be the y value, which is 2x minus 1. Okay. So we want to use our distance formula to find the distance between those 2 points, and then we want to minimize that distance. So let's work through it and see how it goes. So we're going to get that the distance d between this point and this point is going to be what, x minus 2 squared plus 2x minus 1 squared, 2x minus 1 squared. Note that that's just our distance formula from the previous video, just the Pythagorean theorem. So let's work all this out. We get that our distance equals x minus 2 squared is going to be x squared minus 4x plus 4 plus 2x, what's that going to be? 2x minus 1, 2x minus 2. We're going to square it, so that's going to give me plus 4x squared. Multiply them together and double it, so that's going to be minus 4x minus 8x plus 4. Alright, make sure that you can do that. If you need to stop the video and work through that a little slower, that is fine. So now we're going to d equals the square root of 5x squared minus 12x plus 8. I think that's got it. 5x squared minus 12x plus 8. Okay, and now we're back to our old buddy completing the square. We want to complete the square inside here. So what we're trying to get at is we're going to find the vertex, and that's going to minimize d. That's going to tell us when d is the smallest. So that's why we need to complete the square. So 5 times x squared minus 12 fifths x plus 8 is going to be how I complete the square on 5x squared minus 12x. Well, I got to factor out the 5 first, and now I complete the square. It's going to be 5 times x minus b over 2 squared, so that's going to be 12 over 5 divided by 2 is going to be what? Divided by 2, it's going to be 6 fifths. Let me go over on the side, so 12 fifths divided by 2 is the same as multiplying by 1/2, so that 2 is canceled here by the 6 times 2. The 2 cancels and leaves me with 6/5. And now I need to, that's squared, now I need to subtract 36/25 minus b over 2 squared. So 6/5 squared is that, plus 8. Okay? And now distributing the 5, I get that d equals 5 times x minus 6/5 squared minus, now when the 5 goes to the 36/25, think of 25 as 5 times 5, and so it's going to cancel the 5 and leave me with 36/5 on the bottom. That 5 cancels one of the 5's in my 25, which is 5 times 5, plus 8. Okay, and let's see. Let me copy this thing. Edit, copy, edit. There we go. And so now I'm going to, what is all that? Anyway, so now I have that d equals the square root of 5 times x minus 6/5 squared plus, and so let's go a negative 36/5 plus 8. 8 is 40/5. And so what's that going to give me? 40 minus, it's going to give me a positive 4/5. Is that okay? So positive 4/5. And let's see. So now we have it. Make sure. So negative 36/5 and 8. If 5 goes, 8 times 5 is 40. So yes, that gives me 40 minus 36 is 4/5. Okay. So now we want to look at this, and now we want to think for a second. We were trying to find the shortest distance between this line, an arbitrary point on this line, and that point 2, 1. And we've got that the distance between any 2 points is going to be given by this formula here. Now the question is, when is this thing going to be the smallest? When is this d going to be the smallest? Well, it's going to be the smallest when this quadratic here is at its vertex. No, this is a quadratic that opens up, and so it's smallest at its vertex. So where's the vertex of this quadratic? The vertex is at 6/5, 4/5. And so we see that d is minimized when, so d is minimized when x equals 6/5. So that is, this point on the line here is x equals 6/5. And the actual distance at that point when d is minimized is going to be, so when d is minimized, when x is 6/5, this whole term cancels out and we're just left with the square root of 4/5. So the distance d equals the square root of 4/5, which equals 2 over root 5. Multiply top and bottom. We don't like leaving radicals in the denominator, so that's going to equal 2 root 5 over root 5. And so that's the distance, and the point on the line, so when, we're going white here, when x equals 6/5 and we are on the line y equals 2x minus 1. We have that y equals 2 times 6/5 minus 1. And that gives me that y equals 12/5 minus 1 is going to be 5/5. So y equals 7/5. Okay? So that gives me, again here, that point closest to 2, 1 on the line is going to be 6/5, 7/5, and it's closest to the point 2, 1, and the actual distance is going to equal, and we found it over here, or you could just go straight from here and use the distance formula on these 2 points, and you're going to get the same thing. You're going to get 2 root 5 over 5. That was the whole point of multiplying by the square root of 5 times the square root of 5 is to cancel out that radical. Okay, now you may want to, how am I looking on time? Oops, let me get off here before they don't let me upload the video. Try to make this problem make sense, okay? Let me know if you have any questions.